guys! Welcome to my learning video. In today's video, we're going to talk about how to simplify rational algebraic expressions. But before we proceed to that, let's recall first how to simplify our fractions. So in example number 1, 24 over 48. So we need to think of a number that can divide 24 and 48. So that number will be 24. So divide 24 by 24, we'll get 1. And divide 48 by 24, we'll get 2. So the lowest form of 24 over 48 is 1/2. Next, how about number 2? What number can divide 32 and 36? Okay, that number will be 4. Divide 32 by 4, we get 8. Divide 36 by 4, we get 9. So the simplest form of 32 over 36 is 8 over 9. And number 3, what number can divide 35 and 55? Yes, that's easy. That's number 5. So divide 35 by 5, we get 7. Divide 55 by 5, we get 11. So the lowest form of 35 over 55 is 7 over 11. First, that the quotient rule states that if we have a to the power of n over a to the power of m, this is simply the same as a to the power of n minus m. So we're just going to subtract your exponents. In example number 1, we have n cubed over n. So we're just going to subtract the exponent. The exponent in the numerator is 3. The exponent in the denominator is the invisible 1. So subtract the exponent 3 minus 1, we have 2. So this is the same as n raised to the second power. Example number 2, we have n to the 5th over n squared. So again, we subtract the exponent. 5 minus 2, we get n to the third power. In example 3, we have n cubed over n to the 7th power. We subtract the exponent 3 minus 7. We get an answer of negative 4. So this is equal to n raised to the power of negative 4. But remember, we do not accept negative exponents. So if we encounter negative exponent, we bring down the variable together with the exponent in your denominator, so it will turn into a positive exponent. So this is equivalent to 1 over n raised to the 4th power. Okay, so let us take a look at the following examples. This is a combination of your fraction and your exponential expressions. So you can basically deal with the fractions and the exponential expressions individually. So if you want to simplify number 1, you need to think first of a number that divides 6 and 9, which is 3. So divide 6 by 3, I'll get 2. Divide 9 by 3, I'll get 3. So the lowest form of my fraction will be 2 over 3. But we're not done yet. We still need to simplify your exponential expression. b to the 4th over b squared. We just simply subtract your exponent. 4 minus 2, that will be 2. So we have b squared together with your 2 in the numerator. Next, number 2. Think of a number that divides 60 and 25. That will be 5. 60 divided by 5 is 12. 25 divided by 5 is 5. So I'll have 12 over 5 for my fraction. Next, b to the first and b to the first is just simply 1. C to the fourth over c squared, subtract the exponent. 4 minus 2 is 2. So we have c squared. So our final answer will be 12c squared over 5. In the last example, now let's think of a number that divides 45 and 21. So that number will be 3. So 45 divided by 3, this will turn into 15. And 21 divided by 3 will be 7. To your exponential expressions, b to the fourth over b squared, that will be b squared. So we write 15 in the numerator, 7 in the denominator, b squared in your numerator, c cubed over c to the fifth, we get 3 minus 5, which is negative 2. So negative exponent will not be accepted. So we bring it down to the denominator. So it will be c squared. Okay, now that we're ready to simplify algebraic expression, let us first unlock what is the meaning of rational algebraic expression. So rational algebraic expression is a quotient of two polynomials. From the word itself, ratio, it means it's a fraction form. So these are some examples of your rational algebraic expression, or what we call RAE. So 5 over x plus 2 is a rational algebraic expression. 2n over n minus 2 is also a rational algebraic expression. And x squared plus 3x minus 10 over 3x plus 2 is also a rational algebraic expression. So let's proceed now. Now let's answer the next example. So x to the fourth plus x cubed over 5x plus 5. So again, step 1, factor your numerator and your denominator. The common factor in the numerator is x cubed, and in your denominator will be 5. Factoring the greatest common factor, I'll be left with x plus 1 in the numerator and x plus 1 in your denominator. Step 2, reduce the fraction. So I cannot reduce x cubed anymore. I cannot reduce 5 also. So I can reduce your x plus 1 over x plus 1, which is just simply as 1. So now rewrite everything that's left in your expression. So I'm left with x cubed over 5. Last example. So q plus 5 over q squared minus 25. So step 1, factor the numerator, it's still the same. Factor your denominator. Your denominator is an example of your difference of two squares. So let's factor it out. So the factored form of your denominator will be q plus 5 times the quantity q minus 5. Step 2, reduce the fraction. So q plus 5 can be reduced to q plus 5. This will turn out to be 1. And then step 3, rewrite any remaining expression. I'll be left with the numerator as 1 and the denominator as q minus 5. Lastly, to end the video, so when is a rational algebraic expression or RAE in the simplest form? To answer this, a rational expression is in simplest form when the numerator and the denominator have no common factors other than 1.
puso, ating ang labang sa buong mundo.